Okay, so just cleaning up some little details, just walking around looking at that first one. So we have this particle moving on the y-axis. We have a twice differentiable function. That just means you're allowed to take the derivative of twice. So there's velocity and acceleration. Models the distance from the origin measured in centimeters. You are only looking between 35 and 40. So they're honing in just on this section. Must there be a time when the particle's 15 centimeters below the origin? What number are they actually hinting at there? Negative 15, right? If I'm below the origin. So they want to know if my centimeters have to hit negative 15. And what would that answer be, of course? Yes. Okay, and that's the intermediate value theorem. So, but again, you need conditions. So, must there be a time? I'm first going to answer with a yes, there must be a time. In order for me to use my intermediate value theorem, the function had to be continuous. And because it said it was differentiable, that means it implied it was continuous. So S of t we're talking about. Now, some people wrote f of x. There's no f in here, remember. S of t is continuous on the closed interval, 35 to 40. You could go wider, 11 to 40, but they specifically asked about this section. Okay, so I first have to establish that that S of t, again, not f of x, S of t is continuous on the closed interval. Then the IVT guarantees, it's going to guarantee whatever I'm asking, that S of t has to equal negative 15. Again, a couple people have f of x. We're talking about S of t. Has to equal negative 15 since, and then I'm going to show where it happens. Again, S. S of 35 is what to negative 15 is what to S of 40. Less than and less than, right? Okay, so just watch your wording of that. Okay, again, make sure you talk about the function that's actually in the problem. Don't make up a different function. Number 2 said between 11 and 16. So now I'm honing in on just this section. I don't care about any other piece. Just between 11 and 16, I want to know if the velocity is 3.5 centimeters per second. So now I'm looking at the what of this graph or table? The slope. I'm now looking at the slope to see if I get a slope of 3.5, and it's strictly between 11 and 16. So I'm just going to do the math. So I have S of 16 minus S of 11 all over 16 minus 11. I want velocity, so I have to take the derivative. So that's 2 minus negative 8 and 16 minus 11. The two negatives make a positive, so I'm getting 10 over 5 or 2. So am I guaranteed to hit 3.5? No. Okay. What theorem are they hinting at the moment I took a derivative? MVT, M for slope, mean value theorem. Okay. Did I give you a card yesterday? Did you have a blank card? No. Okay. So we're going to get our mean value theorem on here. I thought I did, but I didn't hand it out. You don't have to say anything, really. All right. So let's get the mean value theorem on here. And there's two things you want to know. You want to know the definition and then the visual of it. Okay, so I'm kind of thinking two things when I picture mean value theorem. I'm going to break it up on the back. I don't know why I put that on the front. Definition and then the visual of it. Okay, so the definition, the formula you have to know is f of b minus f of a over b minus a. What's the name of that part of the formula? What's this called, guys? Average rate of change. So the average rate of change equals f prime of c. And when we take the derivative, it's no longer an average, it's an instantaneous rate of change. So a lot of times they don't actually say mean value theorem, which would be nice, but they'll say when does the average rate of change equals the instantaneous rate of change. So we've got to recognize that as mean value theorem. Average rate of change equals instantaneous. Correct. Now visually, so I'm just going to make a graph here. We did a lot of these graphs yesterday. Let's say my function looks like this. Call this A and B. Okay, so what this looks like visually is your average rate of change, which is your slope of your secant line. So I'm going to connect endpoint to endpoint, and we did these graphs yesterday. This is my average rate of change, and again, I'm going to put secant line is equal to my instantaneous rate of change, which is my tangent line. So how many parallel tangent lines can I draw in this picture? 2. If I kind of extend this line out, I would say I could do a parallel one here. And if I extend this line in this direction, I could probably do a parallel one here.
You can only guarantee one, right?
I could guarantee 2 in between this function, or in between these endpoints.
I mean, it's like when you're applying the theorem with algebraically, you can only guarantee one time, right?
Nope, you could have more.
Oh,
Okay, so visually, if they ask you to graph it out, you're connecting the average rate of change, and you're looking to see when it's equal to the instantaneous, the tangent lines. So yesterday we just did a lot of tabular work. We didn't actually find them by hand. So that's what I want to focus on first, is just finding some of these values by hand. Okay, and I'm going to add one more thing. In order to use the mean value theorem, remember it has to be continuous on the closed interval and differentiable on the open interval. So the function has to be continuous on the closed and differentiable on the open for any of this to even apply. Okay, so let's take a look at example 3. Use the mean value theorem and find where the instantaneous rate of change equals the average rate of change. So again, sometimes they'll leave that part out and they'll say find when the instantaneous equals the average, and we got to recognize that as mean value theorem. So there's 2 things you have to check off first. First, you have to ask, is the function continuous, and is it differentiable? Okay, because if your answer is no to those, then this is a waste of time. It doesn't even work. So can you picture what an x squared function looks like? It's a parabola. Is a parabola continuous? Yes, there's no way it can't be. So I'm going to check off that this is continuous. Now, is it differentiable? Well, I don't know until I take its derivative. So let's take its derivative real quick. Derivative is just 2x minus 8. What does 2x minus 8 look like? It's a straight line. Is it continuous? It's good to go. So it's continuous and differentiable. All right. Yep, sorry. Yeah, it's just saying on this interval because the parabola goes on forever. So it's just saying zoom in on this interval. So it's not implying it's continuous. Like the starting and end point. Yes. Yep.
so does it being differentiable just mean that the graph of the slope is continuous?
Basically, yes. Okay, so now we're going to apply the mean value theorem. So I'm going to start with the formula. F of B minus F of A over B minus A equals F prime of C. Great Monday question quiz. F of B minus F of A over B minus A equals F prime of C. Now you just do the work. So you're going to find F of, who's your A and your B. Okay, so F of 6 minus F of 1 all over 6 minus 1. So we got to do a little scratch work here. All right. I'll do 1, you do 6. What are we getting for 6? 2? I already forgot what I got, guys. I'm losing my mind. 1 minus 8 is I got 7. All over 6 minus 1 is 5. So what is that? Negative 5 over 5. Are we getting negative 1 for the average rate of change? Sound good? Okay, now I need the instantaneous rate of change. The instantaneous is just take this guy's derivative. So we already know the derivative up here we said is 2x minus 8. Okay, now you could plug in a c if you want because it's called f prime of c. It really doesn't matter. You could say 2c minus 8. Either way, you're solving for c or x. And now you just solve the question. So I'm going to add 8 over. Add 8 over. I'm going to get 7 equals 2c. Divide by 2. So I'm getting c equals 7/2. Okay. Now here's the deal. Your answer has to fall inside the interval. Does 7/2 fall inside the interval 1 to 6? Yes. So I would say that's my answer. Yes. Not at all. Not at all. Then we're going to reject the answer. Okay, so now again, I'm going to visually show what I mean by this, and I'm going to cheat on my calculator for a minute. Yeah, it's foggy. So I'm going to go x squared minus 8x plus 14. No, not there, I'm not. X squared minus 8x plus 14. All right, so we said we know it's a parabola. And we were only looking, I'm going to check my window, from 1 to 6. So I'm taking this parabola, and I'm only looking from 1 to 6. So let's find some room in there, and let's kind of sketch this out. From 1 to 6, it looks, and you can just ballpark it with me here, it looks like this. It's a little higher than it is there. Okay. So visually, what we found is we're finding the average rate of change, which we said is -1, so we'll connect our endpoints. We said we know the exact moment in time to draw this tangent line. This tangent line is going to fall right at 7/2, and that's what we're finding. So this tangent line is appearing at c equals 7/2. That is the whole point of the mean value theorem, to find exactly where you're going to draw this tangent line so that it's parallel, so it has the same slope. Okay. Now, the only thing that can happen is obviously the derivatives get a little uglier as you go, but we'll just keep talking a couple out here. Okay, let's take a look at this example. I'm going to rewrite this just for a minute to determine if it's continuous. This really represents the what root? Cubed root of x plus 1 squared. So my first question is there any number in the world I can't take the cubed root of? Can I take it of positive numbers? Can I take it of negative numbers? Yeah, so it's always going to be continuous. There's nobody that makes this undefined. Like, I can always take the cubed root.
If it was a square root,
Then it would be different, exactly. So it is continuous everywhere. All right, so now let's take its derivative. What rule am I using to take the derivative? Chain, inside, outside. So I have negative, bring down the exponent 2/3. X plus 1, subtract 1 or 3/3, so to the negative 1/3. Times the derivative of the inside, which just happens to be 1. Okay, and then I'm going to rewrite this for myself because I don't ever leave negative exponents. So I have negative 2/3, and I'm going to move this cubed root of x plus 1 to the denominator. Okay, again, so this is my derivative. Is there any number I'm not allowed to plug in here? No, I can take the cubed root of everything, so I know it's differentiable. Okay, so now I'm going to apply the mean value theorem.
would there be any point where it equals 0?
Yeah, okay, so yes. What number would make this equal to 0?
I meant the whole denominator.
Yep, so go with me. What number would make this equal to 0? -1. Okay. Now remember, it's differentiable, right? But it's differentiable on the open interval. So am I actually counting -1? No, so that's why this works.
I think I already asked this, but I wasn't understanding the answer. If it's continuous and differentiable on the interval, which means that it should work, but the answer you get isn't in the interval,
Then we reject it because it's not in the interval we're looking at.
but that means that the theorem isn't working even though it should.
No, it's working, but we're honing in on just a piece of it.
But the theorem is basically saying that you have a rate of change on that interval. In that interval, there will be a slope. It's the same.
Correct.
So if we're solving for that, but the but the answer we get isn't in that interval, and that means that the slope that's equal to the average rate of change in the interval would be outside the interval.
I'm so lost.
Yeah, I actually have no idea
I don't know what we're talking about. Are you just going with this?
Sorry, I'm.
Dree, I'm coming back to you.
Okay.
Okay. All right. Average rate of change. So I'm going to do my average rate of change and set it equal to my instantaneous rate of change, which is just this guy's derivative, which we just took, right? So minus 2 over 3 cubed root of x plus 1. All right, so crunch out your math on the average rate of change. Need f of 7 and f of negative 1. So again, I would write it as a root, which I did here. If I plug in a 7, I get 7 plus 1 is 8. Cubed root of 8 is 2. 2 squared is 4. So this should be negative 4. If I plug in a negative 1 plus 1 is 0. 0 to anybody is still 0. So I get negative 4 over 8, or negative 1/2, equals negative 2 over 3 cubed root of x plus 1. Easiest way to solve this is just to cross multiply. So I'm going to go negative 4 equals negative 3 cubed root of x plus 1. I would divide over the negative 3, so I'm going to get 4/3 equals the cubed root of x plus 1. How do I get rid of that cubed root? Cube both sides. Okay, so when you cube the fraction, just cube the top. 4 cubed is 64. 3 cubed is 27 equals x plus 1. And then I just have to subtract over the 1. I'm going to think it is 27 27ths. So I'm going to have 64 27ths minus 27 27ths, which should get us 37 27ths. So again, this tells me exactly where to draw the tangent line so that it is parallel to the secant line. Does that make sense on what we're finding? All right, let's try one more, working out this mean value theorem. All right, square root of 3x. Is that a continuous function? Is there any number I can't take the square root of? Negatives, but does that fall within this interval? No. So over this interval, it is a continuous function. Okay. Let's take its derivative. What rule are we using for the derivative? Chain rule. So I have 1/2, keep the inside. So the negative 1/2 times the derivative of the inside, so times 3. And again, I'm going to rewrite it. So that's 3 over 2 square root of 3x. Does that sound right to everyone? Okay, so again, is there any number I can't plug in this derivative? Not within the interval. So 0 is an answer, right? That wouldn't work. But when we say differentiable, it's differentiable on the open, so we're not including the 0. Okay? So I agree, it's not differentiable at 0, but we're not including 0 because differentiable is on the open. So now we can go ahead and apply the mean value theorem. F of 3 minus f of 0 over 3 minus 0 equals f prime, which is our derivative, 3 over 2 square root of 3x. Take a minute and evaluate f of 3 and f of 0. F of 3 just gets us 3. F of 0 gets us 0, so I think I just get 3. 3 over 3 is 1. Equals 3 over 2 square root of 3x. Cross multiply 2 square root of 3x equals 3. Divide by 2. Again, to get rid of that square root, I'm just going to square both sides, so 3/2 becomes 9/4. And then again, the easiest way to bring over that 3 so I don't have a complex fraction is just to multiply by 1/3. Then the 3 and the 9 reduce to a 3, and we should get 3/4. Okay, and again, that's just telling us exactly where to draw this tangent line so that it's parallel to the secant line. So if this function looked like this from 0 to 3, there's my secant line, and I should draw right at 3/4 is where my tangent line would be so that it's parallel. And that's the whole point of the mean value theorem. Okay. Grab your book, and we're going to still focus on the mean value theorem, but there's a ton of weird multiple choice questions here. Let's see. I don't know. Give me a second. Let's try page 179. There's just a million multiple choice questions here, old old AP questions. Page 179. Let's try this number 3 on page 179. The mean value theorem guarantees the existence of a special point on the graph between 0, 0, and 4, 2. What are the coordinates of this point? Okay, so the moment I see the mean value theorem, I'm going to set up my problem. F of between what two values are we going from? 0 to 4, so f of 4 minus f of 0 all over 4 minus 0 equals, okay, so f of b minus f of a over b minus a equals f prime. So what's my f prime going to be? Take its derivative. 1/2 x to the negative 1/2. You got it. So I'm going to set that equal to 1 over 2 square root of x. Now, the math here is easy because they gave you all the answers. What did they tell you about f of 4? 2 minus f of 0, which is 0, all over 4. So I really get 1/2 equals 1 over 2 square root of x. I just need to solve for x, or c, if you want to call it c or whatever, it doesn't matter. So if I cross multiply, I've got 2 equals 2 square root of x. Divide by 2. Square root of x equals 1. Square both sides, and I should get x equals 1. Once I know x, I just need to go get y, and that just always goes back to the one that says y equals. So y equals the square root of 1, which is also 1. So I think I'm going with choice B. Okay. Let's try, 92. So they like to throw these in the calculator section as well. So grab your calculator. Now, usually when it's in the calculator section, it just means the math is a little uglier. It's the same formula, just the numbers get a little fun. So let f be this function, for what value of c is the instantaneous rate of change the same as the average rate of change? Do you see how they didn't come out and say mean value theorem? They're just using the notation. So they want to know when f of b minus f of a over b minus a equals f prime of c. And our interval is from 1 to 4. So I want f of 4 minus f of 1 all over 4 minus 1. Now, they didn't give us f prime, but obviously the derivative is super simple. What's the derivative of x plus the ln of x? 1 plus 1 over x. All right, so we need to evaluate f of 4. So that's going to be, I'm just going to put it in parentheses, 4 plus the ln of 4 minus 1 plus the ln of 1 all over 3 equals 1 plus 1 over x. And I'm just going to type this whole fraction right on my calculator. I want to do that all at once. So I'm going 4, I'm going to use parentheses too. 4 plus the ln of 4 minus, so I'm using parentheses because of the minus. 1 plus the ln of 1 all over 3. Does that number look like your number?
Where's the Allen puzzle? Find Allen, I'm drawing a blank. Under law.
It's next to the 4.
Next to 4.
Thanks, guys.
Where it says,
Got it? No. Next to 4. To the left of the 4. Gotcha. I got you.
No dumb question. No dumb question. Anna, do we have this answer?
Yep.
Mallory, good?
I answered them on the persistences.
Well, that's not the answer to the question. It's the average rate of change. All right. Now, I'm going to store this into alpha A because I don't want to retype that number in. So I'm just going to hit store, and then A is in green right here, alpha A. Store into alpha A.
Where's the store?
Holy
Found
crap.
alpha.
What am I doing, people?
Alpha,
Store, right here, STO. Uses 10 million times in
yeah,
algebra 2.
And then what?
I've never used
Alpha A.
So everyone just should.
And then just enter.
No one uses A. When we choose X.
We can't use X when we're graphing. Store into alpha A. Oh my God. Holy crap, Mason.
Are you kidding me? That's a button?
You should have been using that.
Never use.
We have never used
Thanks,
that.
Mrs. Right
Well, if you had Mr. Hill, you used it.
In algebra 2?
Yeah, we used this a million times.
We never use A.
No dumb questions, though. No dumb questions. Oh my God. There's a whole alphabet on here, guys. You can pick any letter your heart desires. Store into alpha A. Okay, now, anytime two things are equal, the easiest way to solve this is with an intersection. Okay, especially if it's in the calculator section. We want to find where these two functions intersect, which means we're going to graph them to get our answer. So you're going to go to your y equals, clear anything out. We want to graph that ridiculous number, which we called A, so pull up alpha A. We got a lot of calculator work to do, you're telling me. Pull up alpha A, and then type in your derivative, 1 plus 1 over x. Okay, so in the calculator section, anytime two things are equal, you're graphing both sides and seeing where they intersect. So I'm just going to start on zoom 6. If I look at all these choices, they all fall in the 10 by 10 window. Maturity level around here. And then I'm going to get the intersection. So believe it, you all have used intersection before. Second trace intersects.
I've used that one.
Okay. First curve, second curve, take a guess. And it should tell you exactly one of these points.
Wait, how do you get on the second? How do you get on the other one?
It usually jumps there for you, or just hit the arrow button and it'll switch colors. So second,
yeah, got it.
gotcha, okay. If it doesn't jump, just jump to it. Are we getting 2.164? Jeez, maybe I should find
you put
another
in your
calculator one.
No, I didn't.
We'll put it in. I want to find where two things intersect.
No, but I got the answer without doing any of that.
Okay, well, she wants to know how to do this.
So mad right now.
I can't believe we don't know intersection, guys.
That was, I felt like that was so much more work than was needed.
Well, they get, I mean, they're going to get nastier.
You
Huh?
Go to the front of the
Yes.
class and show us how you did that.
You want to see how I did it?
Yeah, I would.
I'll show
You
at the
can
end of
easily
class.
cross multiply and solve.
That's exactly what
Yes.
I did.
All right.
Cross multiply.
Flick back to page 177. Let's try another mean value question here. All right. Question 85 at the bottom. I believe this graph goes with it. This graph above goes with this question, right here. Portion of the graph of a differentiable function f is shown above. if the value c equals 3 satisfies the conclusion of the mean value theorem on the open interval, what is the slope of the tangent line at x equals 3? Okay, so again, they're telling us to use the mean value theorem. So f of b minus f of a over b minus a equals f prime of c. Let me get that in our heads. And our interval goes from -2 to 8, so I need f of 8 minus f of -2 all over 8 minus -2. Okay. I don't have a function to take the derivative of, so I'm going to leave it as f prime of c. What do we know about f of 8? -3 minus f of 2 is 5. 8 minus -2 is 10. So I get -8/10, which reduces to -4/5 equals f prime of c. So the question says, what is the slope of the tangent line at 3? What can we say the slope is? -4/5, because we found f prime. So we didn't have to find the c value. We know the c value is 3. It's telling us c is 3 right here. So -4/5 equals f prime of 3. They're telling us the c value is 3. Okay. Again, visually, let's go ahead and draw this in. We're saying the slope of the secant will have a parallel tangent exactly at +3. And again, that's what that mean value theorem keeps showing. The slope of the secant equals the slope of the tangent. All right, let's go back to, oh no, my book fell apart again. Son of a pup. All right, page before, 176, let's look at 13. Let f be this function. What are the values of c that satisfy the conclusion of the mean value theorem? So there it is again. So let's start with our mean value theorem. I'm just going to use the space up here. F of, what's our b value here? 3. F of 3 minus f of 0 all over 3 minus 0. And let's go get f prime. What is f prime equivalent to? Yes. Okay. Now again, you can plug a c in if you want, or you can just leave it as x. It doesn't matter. All right, so take a minute and evaluate f of 3 and f of 0. Are we getting 0? F of 3, I got 27 minus 27. F of 0 is obviously 0, so I'm getting 0 equals 3x squared minus 6x. 0 divided by 3 is still 0. How am I going to solve this? What can I do? Factor, I can pull out a 3x. And I'm left with x minus 2. And I got to tee it up. And I should get x equals 0 and 2. Now, here's where they get you, so you have to be super careful. Where did we say our answer has to fall? On the open interval 0 to 3. Remember, it's differentiable on the open interval 0 to 3, which means we don't include 0 and we don't include 3. So I have to reject 0, and my only answer is going to be 2.
So could you find that out without doing any math practically, since all the answers are 3, have a 3 or a 0, except for B?
Well, I'm going to say, no, Luke, you got to do the math. And if one of them doesn't exist.
But in this case scenario, would that work?
Luke, don't get ahead of yourself.
I'm trying to go fast.
Leah. Okay, so the definition of the mean value theorem is that it's continuous on the closed, but the differentiable is on the open. So you don't include the endpoints when you're talking about the differentiable part. So when you get your value for c, it has to fall on the open interval, meaning you're excluding the outside interval. So it's always got to fall in between there. And they love asking this question where they give you an answer that's an endpoint, and they got to remember to reject it. Little sneaky part. All right. I've got 5 questions for homework. Looks similar to the practice one we did. You all know the sound, yes.
It was literally just that one.
I thought it was this. I thought we were past it.
It's almost time to.
Sure, you have 2 minutes.